I'm Anil Kumar, and in this video we will understand the technique of sketching a transformed function. I'll not really sketch the function, but I'll teach you how to sketch it. Function given to us is y equals to 3 times f of 6 minus x over 2 minus 7, and the base function is f of x equals to square root x. First step is to rewrite the equation in standard form. We should write this as y equals to 3 times f of, it's good practice to factor out the coefficient of x, which is minus half. So write minus half, left with x, and then you get minus 12, bracket close, minus 7. Now at this stage you can describe the transformation. Vertically stretched by a factor of 3, reflection on y-axis, that is a horizontal reflection. Everything inside is horizontal. Horizontally stretched by a factor of 2. Horizontally translated 12 units to right and 7 units up. That is how the transformation is. Now this transformation transforms all the points on the original function. And how do they map? They map like this. The original function points, let us say, are xy. Then on transformed function, the x values will get multiplied by minus 2. So we get minus 2x, and then you have to add 12. For y values, they get multiplied by 3. So 3y minus 7. So that is how the points get transformed. So any original point on square root x, xy, will get transformed to these points. How does that help? Well, you can actually make a table of values here. I won't do the calculations, but I'll teach you how to do it. The whole idea here is to learn the process. It could be applied to any function. Now, for square root x, what are your key points? The key points are 0, 0 and 1, 1. Square root of 4 is 2. Square root of 9 is 3. So these are your key points. So these x and y values will give you the image points, right? So you can substitute x and y points, calculate. For example, if I write 0 here, I get 12, right? So we get 12, and for y, I get minus 7. If I write 1 here, minus 2 plus 12 is 10, and 1 times 3 is 3. 3 minus 7 is minus 4. For 4 times 2 is minus 8. Will give you 4 here. And for 2, 3 times 2 is 6. 6 minus 1 is minus 1. So let me calculate the last one also. 9 times 2 is 18 with a negative sign. So we get minus 6. And 3 times 3 is 9. So we get 2. So we get these transformed points. And now on a graph paper, if you put these points, it's very easy to sketch, right? So that's a good way of doing it. The second way is following the transformation, right? So let me show you that approximately. So what we have here is, let us say we'll just sketch our coordinate axis, and as far as the square root function goes, square root x is a function kind of like this, right? So the transformed critical points are, let's say, these are your points 1, 1, 4, 2, and say 9, 3. Okay. Now we can do transformation in steps. So let me show you step by step transformation. So first step should be, you could do vertical stretch also, but I prefer to take care of horizontal stretch or compression and reflection first. So here it gets horizontally reflected, so we'll have a function which is reflected like this, correct? And then horizontally stretched by a factor of 2. Stretch means that this point will stretch like this. Do you understand? This point will stretch like this. So you get a flat thing, kind of flatter, I should say. So this is after minus half of x. Do you understand? So this function, this actually I can write this as f of minus half x. Let me write like this. So that is this particular stage. Now at this stage we can do a vertical stretch of 3 and then the translations. Remember, all these stretches and compressions and reflections should be done first and they should be followed by translations. So 3 means each point, let's say this is at 1, and goes to position 3. So it goes stretched like this. So 3 times, so kind of like this. So what you get is that kind of a function, right? And this one will be 3 times f of, we have already compressed it, so let me write like this. So these are rough sketches, but they are fairly accurate, and I hope you're understanding what I'm trying to do. Now the last step should be to perform translations. It's good practice to do it in one step. 12 units to the right and 7 down. So from here you can do 12 units to the right and 7 down, right? So in that case, let us say that is your point. Correct? Likewise, you can do for all other units, right? 12 units down and 7 right. And once you do that, so for all the units, so we went 12, let's say this is somewhere around, I know it's not accurate, but that's what I'm trying to say, right? So basically, what will happen is that you will see a graph which is kind of like this. Is it okay? So that is how it will be, and this point is 12 and minus 7. 12 units to the right and minus 7. So this is 12 and minus 7 for you. Okay. Now from here, you can also write domain and range, right? If asked for, at times, whenever you're dealing with a transformation question, you need to write domain and range, and it's very clear that the domain of this function is x belongs to real numbers, where x is less than and equal to 12, and as far as the range is concerned, y belongs to real numbers, where y is greater than equal to minus 7, right? To get the accurate graph, you can use the transform points, right? I hope with this you should be in a position to sketch any function. I mean, I could have written here f of x equals to x squared or 1 over x or anything, right? Transforming points. So the key thing which you should know is, 1, what are the key points to consider? What is the transformed equation from original to image? And how do you describe this transformation and relate it with the graph? Once you understand all these things, it should be easier for you to transform the function, right? It's always a tricky job, so go through it in steps. That will always help you. I hope it makes it clear. Thank you and all the best. I'm Anil Kumar. You can subscribe to my videos and learn a lot about functions. Thank you.